Okay, so what we're going to do is we're going to take, we're going to use you're our population. So you are our population, and we're going to take samples of size 3 to estimate mu, the true mean hours of sleep for students in this class last night. Okay, so X is the hours of sleep last night, and X bar is the average hours of sleep last night for 3 randomly selected students. So, the sampling distribution of X bar. The sampling distribution of X bar is the sample mean. This gets kind of confusing because we're using the word sample a lot. But that's why it takes a few days. You have to read the book, you have to watch the videos. So the sampling distribution of the sample mean lists all the possible values of the sample mean and how frequently they will occur. So, how many students do we have in here right now? I think we have 9. Let's just list, just by starting, this is the hours of sleep last night. This is our true value over here. True value, this is going to be our parameter over here. Okay, so our parameter, the true value for the hours of sleep for everybody. So Pablo, how many hours of sleep did you get last night? Just give me a nice round number, whole number. 6, okay? Gabby? 8? 7? Carly?
7.
Abby? 2?
5.
5. 7. Tyler? 5. Okay. Okay, so this is, so what's the true average? What is the mean? What is mu? This is my parameter. This is my total population. You're my whole population right now. If we look at a small scale, big population, then hopefully I'll be able to get you to understand a little more about sampling distributions. But that video will help you too. So, find the average. Do you know how to find the average? How do you find the mean? Add them up and divide by how many? So 6 plus 8 plus 7 plus 7 plus 7 plus 2 plus 5 plus 7 plus 5 plus 6 divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's how you find the mean. 6. So mu is 6 hours of sleep last night. So this is my true value. This is my parameter. Okay, I know this. I figured it out, okay? I am going to try to estimate that parameter taking small samples. Okay, you're like, well, why would I try to estimate it if I have it? Because in real life statistics, you're trying to find something out about a city of size 1 million. Are you going to ask everybody in that size 1 million city the question? No. You're going to take a sample of, say, size 1,000 or 500 and use that to estimate. Okay? So we're moving into deciding, is our sample value good? How good is it? So we need to understand about sampling distributions, okay? So now, could I just randomly select 3 people from this class at a time? So this is going to be this is going to be my statistics over here. My statistic, my estimate of mu. Okay, this is going to be my estimate of the true hours. It's going to be my estimate of mu. We'll just call it that. So my statistic, I'm going to find X bar based on samples of size 3. So if I have 10 students in here, how many samples of size 3 can I get? This is 10, choose 3. Okay? 10C3 will tell us how many samples of size 3 I can get. So turn my calculator on. 10, math, PRB, down to 3, hit 3, whoops. And there are 10, there are 120 different groups. So do you really think I want to pick all of them? No, I don't have time to pick all 100. So there are 120 different size 3 samples I can get. 120 different size 3 samples I can get. Do you really think I have time to list all of them right now? No. But I just to give you an idea, okay? So I'm going to take one sample of size 3. So let's just say I pick these 3 right here. So 7, 5, and 6. What is the mean, what is X bar for that sample? So sample 1 was 7, 5, and 6. So these were I picked the last 3 students I asked, and these were the hours of sleep. Add those up and divide by 3. What is the average number of 6? So 6 hours of sleep for that particular group of 3. So now sample number 2. Let's say I pick 6, 8, and 7, the first 3. 6, 8, and 7. What's that average? Isn't that 7? 6 plus 8 plus 7 divided by 3 is 7 hours. It is, trust me. Okay, 7 hours. Okay, so another sample. Let's say I pick the sample 7, 7, and 2. So the third sample, 7, 7, and 2. That's 14, 15, 16 divided by 3. 5 and a third. 5.3 repeating is 5 and a third. Do you see how the different samples I'm picking are giving me different averages? Okay, how many of these could I pick again? 120. There are 120 different groups of 3, combinations of 3 of you that I could pick out. So then, what I could do, each of these, this is if I listed all 120 of these, isn't that a list of numbers? A list of averages? Okay? That is a distribution. Any list of numbers is a distribution. So I have all 120 of those. Could I put those on a number line, a dot plot, and look at the shape of that? Okay? That's why we had the important features of a sampling distribution are shape, center, and spread. We can take all of those sample averages and we can graph them. We could put them on here. Here's 5, 6, 7. I mean, I'm not going to get higher than an average of 8 hours of sleep, right? Because the 8 was the highest number. So I could graph those. I got 6, and I got 7, and I got 5 and a third. I could make a dot plot of all of the averages. So in the end, how many dots would I have on here? I would have 120 dots on here. And I could look at the shape of this average hours of sleep for a sample of size 3. Average hours of sleep for a sample of size 3. And this would be the sampling distribution. Now, do I have to just use the mean? Could I calculate a different statistic from that sample? Could I calculate the range? What would be the range for this sample? Biggest minus smallest is the range. 2. And the range for this? 2. And the range for this? 5. And I could look at all those ranges. I could make a list of all 120 ranges and graph that. You can have a sampling distribution for any statistic that you know or that you make up. So now we're going to actually do one on the next page that we can actually find all of list them all. So